Welcome to the lecture 2 of this course, and in this lecture we will be focusing on vectors and matrices. Concepts related to vectors and matrices are very important for you to have if you want to be in the field of data science, machine learning and AI. And we will approach this subject and we will develop some basic preliminary ideas about concepts in vector and matrices. So with that, let's move on. First of all, we begin with linear algebra. It's essentially a branch of mathematics that concerns linear equations. And when we say linear equation, it is about linear combination and using arithmetic of columns of numbers called vectors or 2D arrays called matrices to create new column or new vectors or to create new arrays of numbers or new matrices in general. And for you, it's very important to have understanding of how these operations are carried out and what they result in. In fact, in order for you to be very familiar with linear algebra, concepts related to vectors are very important, and there are two different ways where you can understand the concept of vectors, which I have come across, and I think both of those approaches are very important for you to have in your frame of mind when you are using linear algebra tool or vector tool or matrices tool in general. The first approach essentially is, when you talk about, is the approach which is known as geometrical approach. So the first approach is your geometrical approach. So here we see vector essentially geometrically and the concept related to vectors geometrically. And second is also the numerical approach that is required for you to understand the concept of linear algebra and also the concept of matrices and vector in general. And there are certain reasons for it. For example, if you know and if you have an intuitive understanding of geometrical notation or geometrical notion of what vector and matrices are, you can do two very important things. First, you can select proper tools to use from the tool set of linear algebra, which is matrices and vectors for sure. And the second, you will also have a very good intuitive understanding of the results by applying that tool sets. So those are the two fundamental things that you will get out if you have a very good understanding of geometrical approach or geometrical understanding of vector matrices and what all those operations mean. Secondly, in the numerical approach, that is also very important, and you need to understand how to represent them. And this numerical approach has also its place, and it essentially allows you to implement the concepts in the matrix, vectors and linear algebra domain for implementing various tasks which are important for data science and machine learning. Okay, so both of these approaches are important, and I will try to allude to both of these concepts when I'm discussing several aspects in the lecture going forward. But one thing I want to point out that typically it's important to recognize that you need to have first of all a geometric concept very clear, and then that will set up foundation for the numerical aspect of vectors and matrices. So I will encourage you to think about vectors and matrices, their different operations, not only from the numerical point of view, but if you have time, please emphasize on also understanding the geometric meaning of those operations, because that will set up a very good foundation on which you can essentially build upon the numerical approaches. So with that, let's move on and let's see what we can do and what are the main things, some preliminary concepts related to vectors and matrices in general. So let's focus on some of the applications of linear algebra, right? Now, linear algebra is related to matrices and vectors, and there are widely used in various engineering applications. Me being an engineer, I've always found out that they're used in several different applications. But apart from engineering, you find their application in computer graphics. That's also a domain that I'm very passionate about, and I've worked in various geometric operations like translation, scaling, and rotation of images or 3D models are essentially carried out by linear algebra operations. Statistics and probability also requires support from linear algebra to carry out various things. For example, if you're carrying out the least square operation, then you might be using linear algebra too. Fourier series and analysis in Fourier series are also enabled by linear algebra tools. Similarly, you can use the concept from linear algebra in optimization too. And linear programming is a field which is focused on linear optimization problem, borrows a lot of concepts from linear algebra. So not only in machine learning domain, but one foundational aspect of machine learning is optimization. In optimization also, linear algebra comes into forte and it helps. Apart from that, linear algebra also finds a lot of applications in graphs and networks. Markov matrices are used on various dynamic system modeling, stock market modeling, and so on, and in economics too. So linear algebra is one of the most widely tools that is used across a wide variety of discipline and is a wide variety of application. With that, we will set up mostly what we are going to discuss is like some important concepts, some very basic concepts that are related to data science, machine learning, and AI in this course. So in this lecture, what we will cover are essentially some very preliminary aspect related to scalars, vector, matrices, and tensor, and that will set us up for various different types of operations that we can do with scalar, vectors, and matrices, which we will discuss in the next lecture.